Hello and welcome to yet another lecture on Basic Electrical Engineering, paper code ESEE 101. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is an overview on electrical energy. Lesson objective. After end of this topic, students will able to understand the concept of electrical energy. So before approaching to the electrical energy conception, we have to understand the concept of electrical heating. James P. Scott Joule, the name that is James P. Scott Joule, discovered the existence or discovered that there exists a definite relation between electrical energy spent and amount of heat that is produced. Joule's law of heating states that the amount of heat produced is directly proportional to the electrical energy expended. According to the Joule, the amount of heat that is produced is directly proportional to the electrical energy expended. If H is the amount of heat produced from W amount of electrical energy, then according to the Joule, H is directly proportional to W, or we can write W is directly proportional to H, or in other words, if I omit the proportionality part, we have to give a proportional constant, that is W equal to JH, where J is a constant that is known as mechanical equivalent of heat, and value of J is 4.18 joule per calorie. That means 4.18 joule of electrical energy is required to produce 1 calorie of heat. So, in order to produce 1 calorie of heat, the amount of electrical energy that is required is 4.18 joule. So, in case of the engineering, we are taking the approximate value of J, that is taken as 4.2. So this is the general conception of Joule's law of electrical heating. Now coming to the another part that is called electrical energy. So we all know that energy is the capacity to do a specified work. So energy is the capacity to do a specified work. Energy can be of many types: mechanical energy, heat energy, light energy, sound energy, nuclear energy, chemical energy, electrical energy, and other forms. So, what is electrical energy? Electrical energy is the total work done by an electric current in a specified time. In general, we can say that if a current of I ampere, if a current of I ampere flows through a conductor of resistance R ohm for T seconds, then the electrical energy, that is the mathematical expression, that is W, is equal to VI T joule. Means where V is the potential difference between the ends of the conductor and I is the flow of current and T is time of flow. So this is the general mathematical expression of electrical energy. So according to the Ohm's law, we all know the mathematical expression of Ohm's law is V equal to IR. If I put those value of V in this equation, that is V equal to IR, so W became I square RT joule or V square by R into T joule. So it is clear that a work of 4.2 joule is equivalent to 1 calorie of heat. A work of 4.2 joule is equivalent to 1 calorie of heat. So the heat that is produced in the wire, that is can be written as Q equal to W by 4.2, that is VIT by 4.2 calorie, or we can write I square RT by 4.2 calorie or V square T by 4.2 R calorie. This is the heat that is produced in the wire is denoted by Q, and it is the work for 4.2 joule is equivalent to 1 calorie of heat that is produced. So, another part of discussion is the electrical power. So the rate at which work is done in an electric circuit is known as electric power. This is generally known to us. The rate at which work is done in an electric circuit is known as electric power. Is known as electric power. So in other words, we can say that electric power of an appliance is the rate at which electrical energy is consumed by it, consumed by that appliance. The unit of electric power is watt, and it is denoted by W. So the mathematical expression of electric power, that is E, is equal to W by T, that is joule per second. Or we can write that P equal to W by T watts, and W is equal to VIT. So W is equal to VIT. So we can write VIT by T, that is VI watts. So P power equal to V into I watts. You can simplify it, that is 1 watt is equal to multiplication of 1 volt and 1 ampere. So 1 watt is the multiplication of 1 volt and 1 ampere. So 1 watt equal to 1 volt into 1 ampere. So the power that is equal to V into I, or we can write I square R, putting V equal to IR. You can write in I square R, or we can write in the form of V and R, that is V square by R. So the power of an electrical appliance is generally expressed in kilowatt. This is the symbol of kilowatt, kW. So we all know that 1 kilowatt is equal to 10 to the power 3 watt. 1 kilowatt is equal to 10 to the power 3 watt. So sometimes power is also expressed in horsepower, the term that is called HP, that is called HP. The power is also expressed in horsepower, HP. So 1 horsepower, that is equivalent to 746 watt. 1 HP is equal to 746 watt, 746 watt. So it is the another unit of power, or the power can be expressed in another form that is known as horsepower. So we have a basic conception of electrical power. Now we will come to the another point of discussion, that is commercial unit of electrical energy. The commercial unit of electrical energy. The commercial unit of electrical energy is kilowatt hour, that is denoted by kWh. The commercial unit of electrical energy is kilowatt hour, that is kWh, or board of trade unit, BOTU, board of trade unit, board of trade unit. So it is the amount of work done when a power of 1 kilowatt is consumed for 1 hour. So it is amount of work that is done when a power of 1 kilowatt is consumed for 1 hour. So 1 kilowatt hour is equal to 1 kilowatt into 1 hour. It is the multiplication of 1 kilowatt with 1 hour. So 1 kilowatt means 1000 watt into 3600 second for 1 hour, that is equal to 3.6 into 10 to the power 6 joule, that is equal to 3.6 into 10 to the power 6 joule. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. The watt hour meter, that is commonly called the energy meter, that is placed in the premises of all the consumers that we have already seen in our household, which is generally records the electrical energy that we have consumed. So the watt hour meter, that is commonly known as energy meter, which are installed in our premises or household in order to record the amount of electrical energy that we have consumed. So this is the general conception of commercial unit of electrical energy. So let us take some examples in order to understand that what we have discussed now, what we have discussed till now. So we have to go through some numerical examples. So the first one is that a 220-volt electric bulbs that takes 1 ampere current and is operated 6 hours per day at the rate of rupees 10 per kilowatt hour. Determine the cost of operation for a period of 30 days. So, the energy that is consumed is given by the multiplication of power and time. So, power is V into I, that is 220 into 1. It is clearly given. And time that is given, that it is operated 6 hours per day for 30 days. So 6 into 30 multiplied by 10 to the power minus 3 to give the 39.6 kilowatt hour. 6 hours per day, 30 days into 10 to the power minus 3, that will give the kilowatt hour, that is the energy consumed is given by 39.6 kilowatt hour. So we have to find the cost of operation for a period of 30 days. The rate is given that 10 rupees per kilowatt hour. So we have consumed 39.6 kilowatt hour. So the total cost of operation is the multiplication of 10 into 39.6, that is 396, is the total cost of operation. So another problem that is given that an electrical appliance takes 1.5 kilowatt in 30 minutes at 220 volt. What is the current input and what is the ohmic value? So first, we all know that energy is equal to power into time. So 30 minutes, it is equivalent to 0.5 or half hour, because 60 minutes is equal to 1 hour. So 30 minute means it is half hour or 0.5 hour, this portion. So power is nothing but the energy by time. So energy is given 1.5 kilowatt hour, that is 1.5 into 10 to the power 3 divided by 0.5, that will give the power 3000 watt. Next, we have to find the input current, that is power is equal to V into I. So V is given 220 volt, 220 volt. So I is 3000 by 220, that is 13.64 ampere is the input current. So another problem, that is power consumed in a domestic house over 24-hour period of time is given as from 6 a.m. to 12 p.m. The power consumed by that domestic house is 1.5 kilowatt. From 12 p.m. to 6 p.m., 2.0 kilowatt. From 6 p.m. to 12 a.m., 1.0 kilowatt. And from 12 a.m. to 6 a.m., 0.5 kilowatt. So we have to find what is the energy consumption in megajoule. If the unit is rated at rupees 10, find the cost of consumption for a month of 30 days. So first, the total unit that is consumed, that is, we all know the total unit that in our discussion that the total unit that is consumed is given in kilowatt hour, that is kilowatt into hour time. So for the first interval that is 6 a.m. to 12 p.m., the time is 6 hours and the energy consumed is 1.5 kilowatt. So it is 1.5 into 6. For the next 6 hours, that is 12 p.m. to 6 p.m., the energy consumed is 2.0. So it is summation, uh, total energy that is consumed, total unit that is consumed, it is the summation of 4 intervals. And each interval is 6 hours, and the energy consumed for the intervals are given 1.5 for the first interval, 2.0 for the second interval, 1.0 for the third interval, and zero point 0.5 kilowatt for the fourth interval, and each of the intervals are of 6 hours. So the total energy consumed, that is 1.5 into 6 plus 2 into 6 plus 1 into 6 plus 0.5 into 6, that is in kilowatt hour. So it is 30 kilowatt hour, that is 30 into 10 to the power 3, that is watt hour. And if I convert it into the joule, so we have to multiply with 3600, that is 60 into 16, that is watts again. So it is given 108 into 10 to the power 6 joule. So we have to calculate it in megajoule. So 10 to the power 6 joule is 1 megajoule. So it is 108 megajoule. So the cost that is given, the 30 kilowatt hour daily, and for daily energy that is consumed, that is 30 kilowatt hour, it is clear. And we have to calculate for 30 days, that is 30 kilowatt hour daily multiplied by 30 and followed by the each unit is rated as 10. So it is again into multiplied with 10. So 30 into 30 into 10, that is 9,000 rupees is the total cost. So the another problem is given that the heat energy required to boil a certain amount of liquid is 100 kilojoule. The heater used to boil the liquid takes 15 ampere at 220 volt, and the heater working efficiency is 95%. Find the time required to boil the liquid. Find the time required to boil this liquid. So we all know that is efficiency is known as output by input. So we have to find the input. So all the data that is given in a mathematical problem is totally based on the output. So it is amount of heat, that is certain amount of liquid. The energy that is required is 100 joule kilojoule. That is the output consumption. All the data that is given in a numerical problem are based on the output characteristics. So the output is 10 into 10 to the power 3 divided by input is equal to the efficiency, that is 95% or 0.95. So from there we can calculate the input, that is 105.26 kilojoule. So the time that is required, we have to calculate find the time that is required to boil this liquid. So time, that is input energy divided by power input. So that is 105.26 divided by V into I. In kilojoule, we are converting it into the joule, and V is the 200 volt and I is 15 ampere. So that is the time that we have calculated, that is 31.9 seconds. So another problem, that is a 100 bulb that draws a current of 750 milliampere. How much time would be required to pass a 50 coulomb charge through the bulb? So we all know that current I equal to rate of change of charge with respect to time, that is I equal to dq by dt. I equal to dq by dt. From that, time can be calculated. This t equal to charge by current, and charge is given 50 coulomb and current is 750 milliampere. That is means 750 into 10 to the power of minus 3 ampere. So it is given that time that is required is 66.67 second. So the another problem is that what is the potential difference across a resistor that is dissipating 100 watt of power while taking 2 ampere current? What is the value of the resistance? So we have to calculate the voltage, that is voltage V into I equal to power. The power is given 100 from that, and the current that is given 2 ampere current that is taking. So the voltage is 100 by 2, that is 50 volt. So we have found the potential difference across a resistor, that is voltage across a resistor. And also we have to find the value of the resistance, that is R equal to W by I square, because W equal to I square R. So value of the resistance is R equal to 100 by 2 square, that is equal to 25 ohm. The value of resistance R is 100 by 2 square, that is the 25 ohm. So the another problem that is given that the voltage and current in a circuit element are given by V equal to 220 sin t V and I equal to 100 sin t A. I equal to 10 sin t A. It is 220 sin t, that is the voltage, and current I equal to 10 sin t. Calculate the instantaneous power and average power that is delivered. So we have to calculate the instantaneous power and the average power is delivered. So the instantaneous power that is V into I, that is 220 sin t into 100 into 10 sin t, it is 220 sin t into 10 sin t, 10 sin t, that is 2200 sin square t, or we can write we can write that 2200 into 1 minus cos 2t watt. So that is the instantaneous power, and the cosine function of average to 0 in the average power, the average value of the power that is delivered is 2200 watt. So in this way we can find the different numerical problem that is related with electrical energy. Thank you.